You are welcome to chemistry class today with Anekwe Christopher GK. You are chemistry teacher, of course. Today we are going to be looking at a very important topic and element in chemistry. But before we begin fully, I would like you to still remember to hit the subscription button, subscribe this particular channel so that whenever I have a video uploaded, it will get to you immediately, and also hit the notification button as we continue. Remember to do that. All right, today we are going to be looking at the topic hydrogen. Hydrogen is the topic of our today's class. Of course, hydrogen is an element, is the first element in the periodic table. And we are going to be looking at it and know what it takes and the relevance of it around us. So by the end of this particular class, you are going to learn the atomic structure and the configuration of hydrogen atom. By the end of the class, you should know how to explain the structure, atomic structure, and the configuration of hydrogen atom. Number two, you should be able to discuss the occurrence of hydrogen. Number three, you should be able to list the isotope of hydrogen, the isotopes of hydrogen. And number four, you should be able to state the properties of hydrogen, then explain the laboratory preparation of hydrogen, and outline the uses of hydrogen. These are the things we want to achieve by the end of this particular video. So we are going to take them one after the other as we continue. Stay tuned. All right. What actually is hydrogen? Hydrogen is the first element in the periodic table. Of course, I said that before. Its atom is the simplest atom and consists of a nucleus with only one proton, one electron, and has no neutron because it has only one proton, one electron, and no neutron on it. Hydrogen gas is flammable and it burns in air to produce water. This is the reason it is named hydrogen, because of what? Water former. It's a water former, and that is the meaning of that hydrogen that is being called water former. Hydrogen, water former. So it is the first element in the periodic table, and it consists of one atom, one electron, but it does not have a neutron in its nucleus. All right. Hydrogen is an unusual element. Why? It has a single valence electron, like the group 1 elements, which are the alkali metals. Yet, it is clearly a gas with non-metallic properties, like the group 7, which are the halogens. He's in group 1 actually, but he does not behave like them. He's just placed there for convenience, but he behaves like group 7. He has no metallic properties. It's a gas. It's not a metal like group 1 elements. So in the periodic table, it is usually placed between group 1 and group 7 to depict its unusual nature. However, most of the cases we see it placed in group 1. It's just to tell us that it has one valence electron, but its character is quite different from other group 1 elements. So it's not an alkali metal. Rather, it's a non-metallic element in its properties and character. All right, what is the atomic structure or configuration of hydrogen atom? Of course, hydrogen has one atom, one electron, one proton. And because of it, that is one electron you can see in the shell of the orbit, the electron shell. Now it has only one electron in the shell. Its orbit configuration is 1s1, meaning that it has only one electron, and in the first shell it has only one. Hydrogen has only one electron in the K shell and therefore needs one other electron to complete its duplets in order to resemble helium. It needs one to attain duplet electron. It has only one electron in the first shell. One is needed to complete its duplet structure, which makes it to resemble helium. How does it occur? How does it occur? Hydrogen gas, of course, is a gas, makes up approximately 1% of the Earth's crust. It is found freely only in a very small amount in the atmosphere. In volcanic gases, hydrogen gas or hydrogen occurs in combination with other elements as compounds such as water. Water contains hydrogen, acid contains hydrogen, alkalis contain hydrogen, and hydrocarbons, they contain hydrogen and carbon. And in almost all organic compounds such as carbohydrate, protein, and fats, they contain hydrogen also. So it occurs in combined state in all of these compounds or in these places. But recent spectrometric study showed that the sun is about 90% hydrogen. Spectrometer the study shows that sun contains 90% hydrogen by mass, and the light being emitted by the sun is pure hydrogen. The light being emitted by the star is pure hydrogen, while the sun contains 90% of hydrogen. That is massive. Sun contains 90% hydrogen, and the star emits pure hydrogen as the emitting energy. So hydrogen has isotopes. It can exist as proton, which is normal hydrogen that has the electron of 1, proton of 1, and atomic mass of 1. Deuterium, when it sometimes exists as a mass number of 2, while the atomic number of 1, then it can exist, which is normally written as D with mass number of 2 and atomic number of 1. Sometimes it can also be written as 2 as mass number D as symbol of deuterium. So sometimes written that way has a relative atomic mass of 2, while tritium, that is the third atomic isotope, sometimes written as T31, which is atomic mass of 3. So the 3 isotopes of hydrogen are what? Proton, deuterium, and tritium. These are the isotopes of hydrogen. Proton and deuterium are similar in chemical behavior. Proton form water usually, is the one that forms water because it's the normal hydrogen, while deuterium forms deuterium oxide, which means heavy water. Deuterium oxide means heavy water, but the proton is the normal hydrogen that forms water. Tritium is an unusual isotope of hydrogen, and it is very radioactive. Once again, the isotope of hydrogen are proton, deuterium, and tritium. We need to note this. All right. The physical properties of hydrogen are what? Number 1, hydrogen is a colorless, odorless, and tasteless gas. Number 2 is neutral to litmus. Number 3 is insoluble in water because only 2% or 2 cm of it will dissolve in 100 cm³ of water at STP. So we consider it insoluble in water. Number 4, hydrogen is the lightest known substance and is 14.4 times less dense than air. Again, is that it has a very low boiling point of -253 degrees Celsius. So it has very low melting point, and is the lightest known substance, is insoluble in water and neutral to litmus. It has some chemical behavior, which are called chemical properties. Chemical behavior. Number 1 is that it accepts an electron from another atom to form a negative hydride ion. Its position, it has a capacity to accept electron. When he accepts electron, it becomes negative. At the same time, it forms a covalent bond by sharing its ionic electron, as in the hydrogen molecule. It can share with itself another hydrogen. They will share to form hydrogen molecule, which is H2. That's not another chemical property. Number 3 is that it donates its lone electron to form a positive hydrogen ion. It can also donate its lone pair and can enter into coordinate bond formation with molecules having lone pairs of electrons. So he can receive, he can donate, he can share. That is one of the physical property, chemical properties of hydrogen. He can donate, he can share, and he can accept. Number 4 is that it is a strong reducing agent as it reduces the oxide of copper, lead, iron, and the zinc to their respective metals when they are heated in a steam of a gas, which gas? Hydrogen. So copper oxide heated with hydrogen, it will reduce the copper oxide to copper. Iron oxide, iron 2 oxide is going to reduce it to iron. So this is the reaction of hydrogen chemical properties. Another chemical property is this: hydrogen combines directly with more active metals to form ionic hydride. Of course, we have sodium hydride, those of group 1 elements or group 2, other ones that are more reactive than hydrogen itself. Even we can note that them through electrochemical series. Those that are more reactive than hydrogen, he can react with them directly to form an hydride, ionic hydride of that particular metal. Something like sodium hydride, potassium hydride, calcium hydride, and all of that. So it can form hydride of some active metals. Number 6 is that pure hydrogen bonds with a pale blue flame and combines with oxygen to produce steam. Of course, 2 molecules of hydrogen, 1 molecule of hydrogen and 1 atom of oxygen is what gives us water. So when water is formed, it means combination of hydrogen and oxygen. It combines with oxygen to form water. That's one of the things we need to know. Another one is this: hydrogen combines directly with halogens to produce halides. It's a powerful, so you can see the hydrogen react, has a lot of chemical properties. 7 of them is that it can react with halogen to form halide. Chlorine is form hydrogen chloride, bromine form hydrogen bromide, with iodine form hydrogen iodide. So it depends on each, and it reacts with halogen. So it's a powerful element in the periodic table that has a lot of chemical properties and even uses. Okay, number 81 is that reaction between hydrogen and chlorine is spontaneous. We need to know that in bright sunlight, but slow in diffuse light. The combination of hydrogen with bromine and that of the iodine is much less vigorous. In respect to that number 7 that we talked, this particular with halogen, the reaction with chlorine is done under lights and is spontaneous. But that of the bromine and iodine, they are less vigorous than that of the chlorine, but it still reacts with halogens to form halides of any of the elements that it reacts with. So that is the chemical properties of hydrogen. All right, how can we test a hydrogen? How can we know that this particular element, this particular substance is hydrogen in the lab? One of the things, or the things we need to do, is this: insert a lighter splinter into a test tube containing an unknown gas. If actually that particular gas is hydrogen, what it will do is that it will burn with a pop sound, because the gas will invariably mix with the air as soon as the test tube is unstopped. So it will burn with pop sound. That pop sound that it will give you is an indication that that particular substance is hydrogen. The test should be done or carried out with small quantity of the gas, of such gas. If it gives you pop sound, lighter splinter or splint in a test tube will give you pop sound. You know that is what? Hydrogen. Okay, what can we use hydrogen for? Hydrogen is used in manufacture of what? Ammonia in Haber process. Number 2 is that hydrogen under high pressure is used is passed through vegetable in the presence of nickel catalyst to give solid fat, which is used as margarine. This is what we call hydrogenation of vegetable oil. Hydrogenation of vegetable oil is being used in that in manufacturing of what? Margarine. Number 3 is that since hydrogen is very light and has a low density, it is used in filling weather balloons. It's used in filling balloons, weather balloons, because of its lightness. Number 4 is that it is used in converting coal to crude oil. Converting coal to crude oil. 5, it is used as a present in Aussie hydrogen flame, which is used in cutting preheated metal. It is used in cutting preheated metal because it's present in high Aussie hydrogen flame. Number 6, it is used in manufacture of plastic. We use it in synthesis of hydrochloric acid. We use to manufacture that. We use it in manufacture of methanol, of course. We use it in production of water gas and coal gas, which are used in as a industrial fuel. Hydrogen is used in several things. It has abundant uses. Lastly, for now, liquid hydrogen is used as a rocket fuel. And that is it. Now, how can we prepare this? We can prepare it in the lab in several ways. Number 1 is that we'll prepare it when metal react with mineral acid, which is it could be hydrochloric acid, it could be HCl, it could be nitric acid, and the hydrogen will be given off. Now, let's take 3 methods that we use in preparing it. Number 1 now is action of zinc on an acid. Dilute hydrochloric acid or tetraoxosulfuric acid attacks metallic zinc with the liberation of hydrogen gas. No heating is required. And when you do that, you're going to have this. Hydrogen gas will be given either with HCO4 or HCl. And in the laboratory, this is the setup. We have it this way. And the hydrogen gas will be evolved. It will be evolved, it will be collected through downward delivery, upward delivery, or upward through the delivery tube. We'll have it through upward delivery. All right. That is the preparation of hydrogen gas. Next one is action of sodium on cold water. When sodium reacts with cold water, sodium hydroxide will form and hydrogen gas will also be evolved. Lastly is action of iron on steam. When you pour a hot water on an iron, of course, we are going to have iron tetraoxides, and hydrogen will also be evolved. These are the 3 ways in which we can prepare hydrogen in the lab. And as we do this, we will get hydrogen gas evolved, and that is it. And for what we have done so far, for further discussion and inquiry, do well to contact me, because we have done what? We have discussed hydrogen, what it is, the structure, and the electronic configuration, the physical properties, the chemical properties, and how to prepare it, the uses of hydrogen. For further discussion and inquiry and for any other thing, get across to me with my contact line you can see here. But remember to hit the subscription button, the red button on your screen, on the top left side of your screen, and in below your screen, you will see notification bell. Hit it also, so that whenever I upload my video, you will have noticed that I've uploaded new video. Thank you for being part of this particular video, and remain blessed, and get ready for the next class. Thank you.